Good morning. Today we discuss about the trigonometric double angles. Yesterday we discussed about the addition and subtraction formula. In one of them, that most important, that sin A plus B is equal to sin A into cos B plus cos A into sin B. This is one more application. Yesterday I already told you about these four relations: sin A plus B, sin A minus B, cos A plus B and cos A minus B. We form two or more than two relations more. Now this is one more relation. If I put A is equal to B, then sin, in place of B I will write here A. So sin 2A into 2 sin A into cos A. Here this is one formula. This another relation is if I write this 2 sin A into cos A upon 1. So this 2 sin A into cos A upon cos square A plus sin square A. Dividing the numerator and denominator by cos square A. So this 2 sin A into cos A upon cos square A and this cos square upon cos square A plus sin square A upon cos square A. So that is equal to 2 tan A, because this cos A and this cos square A is cancelled and remains it's 2 sin A upon cos A, and this is cos square A upon cos square A is 1, and this sin square upon cos square A is tan square A. So this is another relation, that sin 2A is equal to 2 tan A 1 upon 1 plus tan square A. Now after that we take the cos 2A, three different relations, rather four different relations. Cos A plus B is equal to cos A into cos B minus sin A into sin B. Here I put A is equal to B. So this is equal to cos of A. In place of B I will write here A. So cos A plus A cos A into cos A minus sin A into sin A, and therefore cos 2A is equal to cos square A minus sin square A. Now after that we know that sin square theta plus cos square theta is equal to 1. So sin square theta is equal to 1 minus cos square theta, and cos square theta is 1 minus sin square theta. Here I just this cos square A, I am using this relation, and therefore it is written as cos square A, in place of it is cos square theta is 1 minus sin square theta So this is equal to 1 minus 2 sin square A is cos 2A, another relation. Then we have taken that cos 2A is equal to cos square A minus sin square A. Here the sin square A can be written as 1 minus cos square theta. So this is equal to sin square A is equal to 1 minus cos square A. So that is 1 minus cos square A and therefore it is written as cos 2A is equal to 2 cos square A minus 1, and this is cos 2A is equal to 1 minus 2 sin square A. Similarly, we also find this one relation with this cos 2A is equal to 1 minus tan square A upon 1 plus tan square A. We just substituting this cos square A minus sin square A upon 1. That 1 is replaced by this sin square A plus cos square A, dividing again by just the previous way. that we solved in sine 2a, dividing by both sides, numerator and denominator, not both sides. So that is equal to your 1 minus tan square a upon 1 plus tan square a. Here the other relations, that's tan a plus b is equal to tan a plus tan b upon 1 minus tan a into tan b. Tan a minus b is equal to tan a minus tan b upon 1 plus tan a into tan b. This tan 2a is equal to 2 tan a upon 1 minus tan square a. Sin 3a is equal to 3 sin a minus sin cube, 4 sin cube a. And this cos 3a is equal to 4 cos cube a minus 3 cos a. And this tan 3a is equal to 3 tan a minus tan cube a upon 1 minus 3 tan square a. Here we solve example based on this double angle, that cos 2a is equal to 1 minus 8 sin square a into cos square a. I take this LHS and I apply the relation as standard form 1 minus 2 sin square a. As we know that this 2 sin square a can be written as in the form of double angle. I just modify the question. This base of 2a, I will write here cos 4a is equal to 1 minus 8 sin square a into cos square a. So this cos 4a can be written as 2 into 2a is equal to 1 minus 2 sin square 2a. Here sin 2a is equal to 2 sin a into cos a, and therefore I will write here 2 into 2 sin a into cos of a and whole square, and therefore we can write this one as 1 minus 2 4 sin square a into cos square a. So 4 into 2 is equal to 1 minus 8 sin square a into cos square a is equal to RHS. So this is the proof of the question. Here the question is tan 2a. Tan 4a is equal to 4 tan a into 1 minus tan square a upon 1 plus tan to the power 4a minus 6 tan square a. Here I am modifying this left hand side, and I will write here tan 2 into 2a is equal to, as we know that tan 2 theta is equal to 2 tan theta upon 1 minus tan square theta. Here theta is 2a. So we can write here 2 tan 2a upon 1 minus tan square 2a. Here again I apply this tan 2 theta formula in a numerator and denominator. So 1 minus 2 whole square, and therefore we will write here 2 into 2 is 4 tan a upon this numerator. This denominator is coming here in the denominator, and this is written as 1 minus 4 tan square a upon 1 minus tan square a whole square. I just take the LCM and we will write here that 4 tan a upon 1 minus tan square a 1 minus 10 square a whole square minus 4 10 square a upon 1 minus 10 square a whole square. So this 1 minus 10 square a and this is cancelled, and after that we will write here 4 10a upon 1 plus 10 to the power 4a. This 1 minus 10 square a whole square can be written as a minus b whole square is equal to a square plus b square minus 2ab. So that's 1 plus 10 to the power 4a minus of 2 10 square a minus of 4 10 square a and therefore we will write here this 1 minus 10 square a is in the numerator and here 1 plus 10 to the power 4a minus of 6 10 square a, and that is equal to your RHS. So this is 410a and this 1 plus 10 to the power 4a minus 2 10 square a minus 4 10 square a upon 1 minus 10 square a. This is denominator and therefore we will be shifted here, and 410a 1 minus 10 square a, this 1 plus 10 to the power 4a minus 6 10 square a, and this is your RHS right hand side.